Welcome to the newest edition of the Innovation Coffee Break, today hosted by Understand AI. At Understand AI, we automate annotations, and now I will tell you why. For autonomous driving, we need enormous amounts of data. To take passengers safely from A to B, a safe driving vehicle needs to master its surrounding perfectly, with all challenges which are on the way. Since self-driving vehicles typically learn from data, we have to present those self-driving cars with all the weird situations which might apply in real life. Since we want self-driving vehicles to always behave nicely and well defined, we need to present them with many such rare events. A typical use case is that you have a driving function and you want to make sure that it applies to safety standards. So you put this driving function into your car and you have all the sensors, and these are the sensors on the test. And then you put a second sensor set on the rooftop of your car, so that's the so-called rooftop box, and this is the reference sensor set. So let's do a little math. So you have 300,000 kilometers, and a typical average speed would be 45 kilometers per hour, since it includes city as well as highway. And if you do that, you end up with 6,700 hours of driving. If you have cams and a LiDAR, a typical recording frequency is 10 frames per second. So it means with 10 frames per second, we end up with 240 million frames. So there are 240 million frames and they have to be annotated. So on each frame, there are on average 15 objects like cars, buses, traffic signs, and so on. So if you have those 240 million frames with 15 objects each, you end up at 3.6 billion objects to be annotated. This is a lot. And they need to be annotated at quality, because otherwise you cannot make a meaningful comparison between the sensor and the test data and the reference sensor data. So that's the job, to annotate 3.6 billion objects at quality. And this is what we call enormous. So can this be done manually? Manually in the sense that you sit in front of your computer and you draw objects one after another. And the answer is no. This cannot be done manually. Not at this scale, and not even if you have the best labeling crew in the world available. This just doesn't work out. In the past, it was done manually because the projects were much smaller. With ever more complex driving functionality and ever more complex validation requirements, there's also a higher amount of kilometers you have to annotate. And at the scale we talked about, there's only one way you can do that. And this is through automation. To understand automation, you need to understand what manual labeling actually means. The first step is you have to navigate yourself through the LiDAR scan and through the cam footage. So what you typically have is you have a LiDAR scan with corresponding cam footage, and the LiDAR scan is a 360-degree LiDAR, and then you have a variety of cams, maybe 8 or so, which then cover the same area from a cam perspective. Typically, there's a different angle and a different coverage for each cam and also for the LiDAR, and this is what makes it somewhat tricky to navigate yourself in this space. So once you did that, that's the first task. We assume it takes around 20 seconds on average. Then you move on to the second task. So now you know where objects are located, at least roughly. And now what you do is you do object detection. So this means within your 3D world, like in a game, you're navigating close to the object you detected. Let's say it's a car. And then you start drawing an as tight as possible box around this car. So you do that in 3D space, so you're doing a 3D box around that car. This task takes roughly 15 seconds on average to draw that box. Then you move on to the next task, so that's now the third task. It's typically not enough to just have a box which is classified to be a car or a pedestrian or a motorcycle, for example. What you also need is certain attributes which better describe the object. So let's say you have a car. You would also be interested in turning signals, braking lights. Is it an emergency vehicle or not? Are there caution orange lights on or not? So these are the things you would need to know in addition. Or is it a moving, or if it's a static object, is it parked, and so on and so forth. And these are the attributes you assign in addition to your box to each of those objects. So there's a long list, and you go through it list one by one. You look at the cam footage, and then you say, okay, the blinker's on or blinker's off, and you move through that list. So this task takes another 10 seconds on average. But that's still not enough. There's at least one more step which is absolutely important. To achieve desired quality levels, what we do is we have a second person looking on each of those annotations and making sure that it's actually a correct one, so that it is of high quality, high enough quality. So that person moves through every annotation and then checking if the box is tight enough, if it's the right class, if it has the right attributes on, and so on and so forth. We assume that this takes another 15 seconds on average. So if we sum that up, we end up on 60 seconds for a 3D bounding box with all annotations at the desired quality level. This is how long we would assume it takes if you do one box after another. Let's do a little napkin calculation. From our example before, we ended up with 3.6 billion objects. If we now assume that it takes roughly 60 seconds or 1 minute per object to get it annotated manually, we end up with 60 million hours of work. Now let's talk automation. Understand AI developed the automation engine to bring down the times from 60 seconds to a significant lower amount of time to speed up those projects, to bring down prices. I now want to take the chance to explain how that is done. We start with automated object detection for cars, for example, via deep learning-based networks. Then we track those objects across frames and link them into chains. Finally, we snap those objects to the perfect size via deep learning-based regression. With the Understand AI automation engine, data can be processed up to 15 times faster than manual labeling and up to 5 times faster than traditional automation approaches. This saves you cost and time. Sounds interesting? Contact us if you want to learn more.
DSpace, your partner in simulation and validation.